So, hello guys. Today we will do the part 6 of exercise number 5. So, in the last video we end up in this point on the presentation of the vehicle and moving load case. Okay, so let's do the rest. Let's work on the rest. Let me shift to robot structural analysis. So I'm going to View menu, display. I'm going to turn on the moving loads and moving load vehicle option. Okay, here on loads, moving loads already checked. Okay, apply. And as you may see, I'm also going to select load number 5. It's the only one that has moving loads. Okay, and now let's go to loads menu, select case component over here and select component number 5. Okay, there you go. And now I'm going to press the animation button. I'm going to press the start button. And as you may see, we can check in an animation the various steps of this moving load on the structure that we have. So now I'm going to close this. Okay, that's a really neat feature by robot structural analysis. Now let's switch to the results tab or the results layout. This layout will be divided in 3 parts. We have the graphic viewer over here containing the structural model. We also have the diagrams dialog box and also the reactions table. For all the combinations we have the reactions over this table. So let's switch to view, go to deformation and choose deformation. I'm going to apply. Sorry about that, I have to change to moving crane. And here we have the deformation for the moving crane, as you may see. Now I'm going to make an animation. So I'm also going to loads menu, select its component. I could also do this, just go to this button and select the case component. I'm going to select component number 5 and check an animation. And as you may see in this animation, we also got the deformation from the structure. You could ask any quantity that you would want. I'm just checking the deformation as the moving crane is actually moving. Okay, now I'm going to close this, stop the animation, close this, and close the deformation. I'm going to go to a layout which for me is one of the best. Over here, let's go to steel design, steel aluminum design. Once again, I have here the graphic viewer. I have also the definitions. I have also the definitions dialog box and the calculations dialog box. Okay, I'm going to enter the numbers 1, 2, 6, and 7. Okay, already shown here 1, 2, 6, and 7. And I want all the load cases over here. Limit states, ultimate limit states, all the load cases. Okay, all the load cases. I'm going to copy this, close, and paste it right here. Okay, and now I'm going to run the calculations by pressing this button, these calculations, and here we've got our results. We have got our ratios, and now we are going for the simplified results for member number 2, column number 2 over here. And you may check here the simplified results for this member. Okay, now let's close out of here, let's press OK, and let's define now a group. So I'm going to the definitions dialog box. I'm going to groups. I'm going to create a new group. The member list will be 1, 2, 6, 7. The name of the group will be columns, and the material will be steel. Okay, I'm going to save this to define this group. Press OK. You need to remember one thing. When you make a group analysis on the steel member definition, the material that robot is going to use, it is this one that you define here. You could have different material on all of your columns, but I'm just going to define this material for all the columns in this process here. Okay, now let's click OK, save and OK. Let's close out of here. Let's go to code group design, pick list and pick this group columns. Okay, let's switch on the optimization options and select weight. So now I'm going to change to OneNote. Here I am in OneNote. As you may see, I'm going to choose this. So as you may see, when I select the weight, selecting this option results in recognizing section weight in optimization, the lightest section on the group amongst the sections available, which will be the EPE, will be selected. So if I have got something like, let me just change the color over here. If I have something like an EP E500 and an EP 400 meeting the code criteria, robot is going to pick this one, which is lighter than the former. Okay, so let's switch once again to robot structural analysis. Here we are. Okay, I'm just going to choose ultimate limit state and run the calculations. There we go, and we got a lighter element, an EPE 330. Okay, so now I'm going to press this button over here, the change all button, and robot is actually going to change the elements on my structure, as you may see. So I'm going to display bars and section legend by columns. You are going to see the colors changing. Sorry about that, I'll need to redo something. I'll need to select all the columns. Okay, I have just picked the columns 1, 2, 6, and 7, as you may see. I also want the other columns, otherwise this will not be done correctly. So I'm going to change to a top view with a control key pressed. I'm going to select this, this one, and also this one. I'm going to change the view pressing shift. As you may see, I have already selected all the columns. Here they are. I'm going to copy this to the member list, paste, save, OK. Now I am able to run the calculation because all of the elements are correctly defined. I'm going to run the calculations, and there we go. We also have got an EPE 330. So I'm going to press change all and notice the colors on the back of the structure. If I press this, these colors have changed. So now the results are out of date, as you may check over here. I'm going to press the calculation once again. Program is calculating the structure, and now I will run the calculations here once again. This is an iterative process. Now I have a 300 going to change once again. This is the optimization process that I have already talked about in previous videos. So I'm going to stop right now, run the calculations once again so that the results are available over here. Now let's switch to influence lines, okay? I'm going to close this, structure model, start. On the results menu, advanced influence line, I'm going to pick the MY moment, which is the moment regarding the greatest or the strongest axis. Okay, I'm going to pick the element number 68, which is the left crane girder. In the point field, I'm going to set the position 0.25. This means that robot, here I have bar number 68, and this is position 0, this is position 1, this is position 0.5, and this one here is position 0.25, and here 0.75. Robot is going to draw the influence lines for this position over here, okay, which is 1/4 from the beginning. Right, so the range will be 1 to 35. Okay, I'm going to apply, and here we have the influence lines correctly drawn. So now I'm going to right mouse click on influence line viewer and press add coordinates over here. And what this is going to do, as you may read, the table located on the diagrams of influence lines will display additional columns containing the coordinates of the suspected structure points, as you may see. Okay, just information shown here. So now let me change and make the influence lines for the FZ shear force. In this case, I'm going to turn this off, turn this on, and also apply the same thing. And as you may see here, the shear is correctly drawn. So now we have finished this exercise. This video was longer than the previous ones, so I thank you all for bearing here with me, and I hope you guys come back. Thank you very much.